Hey everybody, in today's video we're going to be looking at like terms and unlike terms. In the last video we ran through all the different terminology that we're going to be using for this unit. One of the parts that we looked at was terms. Terms are separated by an addition or a subtraction. If it is a multiplication or a division, that's still part of the same term. So it's only separated by addition and subtraction when we're looking at polynomials. Like terms are terms that have the same variables raised to the same exponent. For example, if we had 2x squared and negative x squared and 350x squared, it all has the same variable and the same exponent because the variable that we're looking at is x and our exponent is squared. Now our coefficients in front of our variables can be different, and that's going to come into play in how they add together or subtract from each other, and it's going to determine our answer. So when we're looking at like terms, they have to have the same variable, which is x, and the same exponent, now in this one, would be 2. Unlike terms are terms that have different variables or the same variables but with different exponents. Now an example of this could be 2x squared and x and negative 6x cubed. Notice the variables are the same, but the exponents are different. So these would not be like terms. You could also have something like, close that, 2y squared, and because the variable is different, it is not a like term. Now, our goal is to always simplify and combine the like terms, which means we're going to add or subtract them. So once you find your like terms, you want to add and subtract amongst the like terms to simplify your expression. In the example 1 here, it says to circle the terms that are like. So we want to find terms that are going to be like 5x. Meaning we have to have a variable of x and an exponent of 1. 2x would be an example. 7 has no variable, so it wouldn't be. 6xy, now we do have the variable x, but because there is also y, it is not a like term. Negative 5x would be an example of a like term. And 6x squared, because it's squared, so our exponent is 2, this is not a like term. For b, it says 6xy squared. Notice that the squared is on the y, so it can't be on the x to be a like term, and the like term has to have an x and a y in it. The first one is 2xy. It does not have a squared on the y, so it is not a like term. 3x squared y, the squared is on the wrong variable, so it is not a like term. 2xy squared, we have the x and the y is squared, so it is a like term. And we have xy squared, and this as well would be a like term because we have the variables x and y, and the squared is on the y. In example 2, it asks us to simplify, so we're looking at combining like terms. The first one is x plus 2x. Because our variables are both x and the exponents are the same, we're able to simplify this in combining the like terms. The way we go about this is simply adding them. Whenever there's no number in front of the x or in front of the variable coefficient, it means it's always 1, which we learned last class. So we have here 1x plus 2x, which combines to make 3x. It's just simply adding them together. If we had 5x, subtract 3x, now our variables are the same, exponents are the same, so we can combine these. We'd go with 5 subtract 3, so you're looking at 2x. For C, we have 5x subtract 3x squared. Now, our variables are the same, but because there's a different exponent on the x for the negative 3x squared, we cannot combine these because they are not like terms. So what we would put down is cannot combined, no like terms. Looking at D, we have 5x and then in brackets 2x. So we have a multiplication here. If it is a multiplication, it is not the start of a new term, so that means we can't combine these together. So when we're looking at this, multiplying so you can't combine. So cannot combine. In our last one, we have 5x plus 2x squared subtract 6y. The first thing I always look for is, do we have like terms? Well, we have x as our variable in one of them, then we have x squared as our other, and y. So all of these are different. Even though we have a variable of x and x squared, the exponents are different, so we cannot combine these together. So what we would put down would be that we cannot combine because there's no like terms. So cannot combine, and there's no like terms. Next, we're moving on to is 14x squared subtract 11 plus 30x plus 3 plus 15x subtract 25. When we get into longer expressions like this, I like to use boxes, underlines, and circles to help me separate the different like terms. So what I'm going to start off with is the 14x squared. So that means I'm looking for any like term that has an x squared. And what I'm going to do is I'm just going to kind of box it underneath. So wherever I see an x squared, I'm going to box it. One thing that I find always helps so that you know if it's a positive or negative is to make sure that wherever you're boxing or circling, you're including that plus or that negative, so that addition or subtraction, because that will travel with it when you're moving them around. So our x squareds we have grouped together. The next one I'm going to look at is my constant, which is negative 11. So I'm just going to circle my negative 11. And then I also have a constant of plus 3. And that means that my last stuff that I have to deal with is the 30x. So where the variable is just x with no exponent on it. And I'm going to underline the 30x and the 15x. Remember, when we're putting these down, we have to put them down according to standard form. So we want to go numerically from highest to lowest, and we want to go alphabetically, so from A all the way to Z. Now we only have the variable x in here, so that means we're going to be looking at going numerically with highest to lowest for the exponents. So meaning we have x squared that has to be first. When we're putting this together, we have 14x squared and negative 25x squared. Then we have to deal with x, which is plus 30x plus 15x. The last part is the constant, so negative 11 and plus 3. Now we have them all grouped together. When we're looking at the 14x squared, subtract 25x squared, we're left with negative 11x squared. And we did that by 14 subtract 25. The second part we have to look at is the 30x plus 15x. I should have made that go a little bit further. So 30x plus 15x gets me plus 45x. And the last part is my negative 11 plus 3. So negative 11 plus 3 leaves me with negative 8. So I've combined all my like terms. The first thing I did though was I put them in order, I grouped them. Then I solved for them by combining them together, doing the adding or subtraction, and I'm left with negative 11x squared plus 45x subtract 8. In the next example, we have 4n squared subtract 1, subtract 3n, subtract 3, plus 5n, subtract 2n squared. I'm going to start off with looking at what my variables are, and my variables are only n, meaning I have to look numerically now at the exponents, which are going to be listed highest to lowest. So I want to look at 4n squared. I'm looking for any other n squareds, which are going to be negative 2n squared. Then I have my constant, which is negative 1. I'm just going to circle this negative 1. Another constant, negative 3. And then the last one is negative 3n and positive 5n. Writing this down, I want n squared first. So I have 4n squared, subtract 2n squared. Next is my variable of n without any exponent, which is subtract 3n plus 5n. And the last thing is my constant, which is negative 1 and negative 3. Grouping these together, so I'm combining my n squared, and I get 4n subtract 2n squared, which is 4 subtract 2. So 2n squared. Then I have negative 3n plus 5n, which gives me positive 2n. And my last part is negative 1 and negative 3, which gives me negative 4. And that would be my final answer for combining the like terms. In the next one, we have 4xy subtract y squared, subtract 3x squared, plus 2yx, subtract x, subtract 3y. I can see right away that I have two different variables involved here. So I have x and y. Sometimes x and y are together, and sometimes they are separate. So remember, when you're putting this down in standard form, you need to have them numerically by exponents and alphabetically from A to Z. But first thing I'm going to do is underline, circle, or box my like terms to help me organize this. So I have a 4xy. I'm looking for any other xy. Well, I have a plus yx. Because they're multiplying in this, they can be flipped around and still be treated the same. So if I have a 4xy, it's going to be the same as my 2yx. When I combine them, I can choose which way I want to write this. Then I have my y squared. Don't forget to circle your negative in there. So I'm looking for any other y squared, which is Well, there isn't any. After that, I have my negative 3x squared, so I'm looking for x squared. I'm just going to do a full box on this one. So any x squared, well, there is no other x squared. Then I have negative x. Well, there's no other x by itself. And then I have y. Well, let's do an overline. So I have negative 3y. There's a lot in this equation that isn't actually going to be able to be combined together due to us having so many different variables with different exponents on them. But we'll have to worry more so about the standard notations so that we're putting it in the correct order. First thing that I want to have written down is alphabetically x. Now, if I'm going x first, I have to have my highest exponent, so we're going to be looking at x squared. The only x squared that I have is negative 3x squared. Following x squared, I want to write down anything that's going to have x to the power of 1. So x by itself. Where I have x by itself is negative x, and I also have x to the power of 1 when it is xy. So I would write that following x by itself because y is my next letter in the alphabet. So what I have is 4xy and also 2yx, meaning I would write down plus 4xy. Now there is no plus in front of this, but if there's never anything in front, we always know that that is a positive number, because if it was a negative number, they would have a negative listed. Whenever there's nothing there, it means it's positive. So we have plus 4xy and plus 2, and I'm just going to write it as xy, so we have it the same order. The next thing we want to look at is y, and remember, we're working with anything numerically higher and then going lower. So we have negative y squared, and then we have negative 3y. So we're going alphabetically in order and then also numerically in order. Next thing I want to look at is what can I combine in this? Well, there's no other x squareds. X by itself can't be combined because there's nothing else. The only thing we can really combine here is this portion right here. So we have 4xy plus 2xy, which gives us 6xy. The rest is going to be written down the same. So negative 3x squared, subtract x, plus 6xy, subtract y squared, subtract 3y. And that's how we would finish off our question. Next question we have here, we're going to be thinking back a little bit to what we did last unit, where we're looking at perimeter. Now perimeter, remember, is the distance around the outside. What we need to do here is we need to add up all of these unknowns, so all of these variables, to figure out our total perimeter. If this side here is x, that also means this is going to be x because these are all squares, meaning this is also x, this is also x, and this is also x. So we have x listed all the way around the outside of this. The only thing we have to do in this is add them all together. So we have 1, 2, 3, 4, 5, 6, 7, 8. We add all of our like terms together, and we get 8x as our perimeter for the rectangle. In the next question, we have 1 listed as our width and x listed as our length. So that means x is going to be the same length on the top, and 1 and 1 are going to be the same widths on the side. Again, we're looking at combining all of our like terms for the perimeter, which is the distance around the outside. So just like we did when we had the expressions written out, we want to look at how many we have of the like terms. I'm going to start off with my variables. So we have 1, 2, 3, 4, 5, 6 x's, meaning I'm going to write 6x down. And then we have 1, 2, 3, and 4 ones, which adds up to plus 4. So we have 6x plus 4 as our perimeter for this rectangle. Again, remember that you have to find your like terms, combine them together, and then list it down in standard form. On the next page, we're going to try these, and we're going to simplify by combining these like terms. First thing I want to look at is what are my like terms. Remember, terms are broken up by addition and subtraction. So we have 3x, negative 2x, positive x, and positive 7x. All the variables on here are x, meaning we're going to be combining all of these together. So we could rewrite all of this, but because they're all the same variables, what we need to do really is just add them together. So we're looking at 3 subtract 2, which makes 1, plus 1x makes 2, and the last part is plus 7x, which leaves us with 9x in total. So we've simplified that whole expression, equation, because it does have an equal sign on it. The next part, we have 4a plus 7a subtract 3a. All of our variables are the same, so we're just going to be combining these together. So we have 4a plus 7a, which makes 11a, subtract 3a, which leaves us with 8a. C, I'm going to leave for you to do on your own. Remember, look at the variables and make sure that the exponents are also the same on the variables. For D, we have 8a subtract 7c plus w. First thing you should be looking at is, are the variables the same? No. Are the exponents the same? Well, the exponents are the same, but it doesn't help us because none of the variables are the same. So we have 8a subtract 7c plus w. That's as simplified as we can get on this equation. For E, we have 6x squared plus 7x squared plus 3a subtract 7a. So we have variables of x with an exponent of 2 on it. So this one here and this one here, we're going to be able to combine. Then we have 3a and negative 7a, which we can also combine together. 6x squared plus 7x squared gives us 13x squared. And then we have positive 3a subtract 7a, which leaves us with 4a. And that's combining the like terms, and that's as simplified as we can get on this question. For F, we have 7y plus 3x subtract 5y plus 6x subtract 10y. Our variables that are in play in this equation are y with the exponent of 1. So I'm going to look for my other y's with the exponent of 1. And then I have my 3x, so x with the exponent of 1. X with the exponent of 1. Now remember, I'm putting this in standard form, so alphabetically, I have to go x first and then y. So I'm going to write this out on the side with 3x plus 6x. Then I have my y, so I'm going to have plus 7y subtract 5y subtract 10y. First part I'm looking at is my x's and combining them together. So 3x plus 6x gets me 9x. Then I have my y's that I want to put together. So I have plus 7y subtract 5y subtract 10y, which gives me negative 8y. And that would be as simplified as we can get on this equation. For g, I'm going to leave for you to calculate on your own. Remember to pay attention to the variables and also pay attention to the exponents. The variables have to be the same and the exponents have to be the same. For h, it says write a polynomial for the perimeter of the shape and then simplify the polynomial. On the lengths all the way around this shape, we have y, we have x, we have y, and we have x. So there's two variables involved here, but the variables have the same exponent. So I'm going to go and circle all my y's. So I have a 3y and a 3y. Then I also have an 8x, a 5x, and a 5x. Remember, standard form wants me to write this alphabetically in order, meaning I have my x first. So I'm going to have 8x plus 5x plus 5x, then plus 3y plus 3y. To combine my like terms, I want to put 8x plus 5x together, giving me a total of 18x. And then I have my y's, which is plus 3y, gives me positive 6y. And that's going to be as simplified as we can make this perimeter. That's going to bring us to the end of this lesson today. Make sure if you have any questions, send me a message on Teams or ask me in class when you see me.